So this video is basically an introduction into organic chemistry. I'm going to try to cover the major topics that you're going to see as you take this course. So let's begin with nomenclature and drawing structures. So the first thing you need to know is the first 10 alkanes. For example, like methane. Methane contains one carbon. That's CH4. Next we have ethane. Ethane has two carbons, C2H6. Now you can draw it this way as well. This is the same as CH3, CH3. As a line structure, it looks like this. Every endpoint of a line structure represents a carbon. Propane has three carbons. It's C3H8. And as a line structure, it looks like this. Butane has four carbons, which looks like that. The next one is pentane, which has five carbons. And hexane has six carbons. 2, 3, 4, 5, 6. Heptane has seven carbons. 2, 3, 4, 5, 6, 7. Octane has 8. Nonane has 9. Decane has 10. So make sure you commit to memory those 10 names. So let's say if we wish to draw a Lewis structure. Let's say you want to draw 2-methylpentane. So look at the parent name, pentane. So you have five carbons, 2, 3, 4, 5. Now you also have a methyl on carbon 2. So if we count from left to right, this is carbon 1, 2, 3, 4, 5. So there's a methyl, which is a CH3 on carbon 2. Now keep in mind, methane is CH4. But when you see the word methyl as a YL, it's a substituent, and it's CH3 because the extra connection is attached to the chain, which is this 5-carbon network that we see here. So knowing that, how would you draw 3-methylhexane? So to draw it, draw the 6 carbons. Draw hexane first. 2, 3, 4, 5, 6. And on carbon 3, we have a methyl group. Try this one. 2, 2, 3, 3. Tetra. Tetra stands for 4. Tetramethyl butane. So butane has 4 carbons. And we have 2 methyls on carbon 2. So let's say this is carbon 1, 2, 3, and 4. And we also have 2 methyls on carbon 3. So that's 2, 2, 3, 3 tetramethyl butane. Now let's say if you want to draw 2, 3 dimethyl pentane. So pentane has 5 carbons. On carbon 2 you have a methyl, and on carbon 3 you have a methyl. Try this one. 3-ethyl dash 2,4 dash dimethyl octane. So to draw it, start with octane, which has 8 carbons. 2, 3, 4, 5, 6, 7, 8. On carbon 3 you have an ethyl. An ethyl contains 2 carbons, CH2, CH3. And on carbon 2 we have a methyl, and on carbon 4 we have a methyl. So it's very easy to draw it. And the reason why I'm drawing the Lewis structures first, or the line structures, is so that when it's time for you to name it, it's going to be very easy for you to do so. Now keep in mind, we can draw it this way as well. The methyl is simply can be represented like that, and ethyl would be 2 carbons. So this is ethyl, and here we have methyl. So now let's say if you want to draw this structure, 2-chloro dash 3-bromo heptane. How would you do it? So again, start with heptane, which has 7 carbons. That's 4, 5, 6, 7. On carbon 2 we have a chlorine atom, and on carbon 3 we have a bromine atom. And that's really all you have to do. Now there's some special substituents that you need to be aware of, and let me go over it at this point. So let's say if we have these substituents. So this is a methyl, this group is an ethyl, and this is a propyl, and this is a butyl. As you can see, methyl has 1 carbon, ethyl has 2, propyl has 3, butyl has 4 carbons attached to the parent chain. And they don't branch off, they continue in a straight line. Now, if you hear the word isopropyl, it branches off. It has 3 carbons, but notice that it doesn't extend from the chain in a straight line, it branches off. Isobutyl does something similar too. That's isobutyl. At the end, it branches off in 2 separate directions. So this is isopropyl, and here we have isobutyl. Isopentyl looks like this. It has a total of 5 carbons, and at the end it branches off. Anytime you hear the word iso, at the end you have those 3 carbons that branch off. Now there's some other terms you need to know, like tert-butyl, which looks like this. So that's tert-butyl. And the other one you need to know is sec-butyl, which splits off that way. So that's sec-butyl. Now let's go back into drawing other structures. Let's say if we want to draw 2-butene versus butane. Butane is an alkane. An alkane only contains single bonds, carbon-carbon single bonds. Alkanes are also known as saturated compounds. Every carbon atom is filled with hydrogen atoms. Here we have an alkene, particularly a double bond on carbon 2. This is 1, 2, 3, 4. It's between 2 and 3, but this number is based on the lower of these 2 numbers. So this is an alkene. And let's say if you want to draw a 3-hex sign, notice the YNE, that's an alkyne instead of an alkene. And alkynes, they contain carbon-carbon triple bonds. So we have 6 carbon atoms because it's hex sign. And on carbon 3, we have a triple bond, which is really between 3 and 4. So that's 3-hex sign. That's how you draw it. Alkenes and alkynes are known as unsaturated organic compounds because they're not filled with hydrogen atoms. You can add more hydrogens to it. So if you have, let's say, an alkene, and if you add 2 hydrogens, it's going to turn into an alkane. This reaction is known as hydrogenation. It's a type of addition reaction. But let's move on. So now let's practice naming structures given the line structure. So feel free to pause the video and go ahead and try to name this compound. So the first thing you want to do is you want to count the parent chain. You want to find out how many carbon atoms are in the parent chain. Now you want to count it from left to right and not right to left, because if you count it from left to right, notice that you have a methyl on 2 and 3. If you count it the other direction, this would be 1, 2, 3, 4, 5, 6, 7. The methyls will be at carbon 5 and 6 rather than 2 and 3, and you want to pick the lower numbers. So to name it, it's going to be 2, 3 dimethyl heptane. So typically you use a comma to separate numbers and a dash to separate a number and a letter. Let's try another example. So let's say if we want to name this compound. So first find the longest chain. 1, 2, 3, 4, 5, 6. Now we're going to count it both ways, and we're going to write the name using both directions, and we're going to see which name makes more sense. So this is an ethyl group because it contains 2 carbons, and this is a methyl because it contains 1 carbon. So we have to alphabetize it. ethyl comes before methyl. E comes before M. So to write it, it's going to be 3 ethyl, 4 methyl, and 6 correlates to hexane, so 4-methylhexane. Hexane is the parent chain. Now, if we have it in the other direction, it's going to be 4 ethyl, 3 methyl, hexane. In both cases, the substituents are alphabetized, which is good. If you have a choice between 3 and 4 and 4 and 3, you want to arrange the numbers in increase in order, if the option is available. But make sure you alphabetize it first, and then if possible, arrange the numbers in increase in order. So the right answer is this one. Okay, so let's try this example. So, should we count starting from the left or from the right? Well, B, bromo, comes before fluoro. So we want bromo to have the lower numbers. So we're going to count from the left. 1, 2, 3, 4, 5, 6. So when we name it, it's going to be 3 bromo, 4 fluoro, rather than 4 bromo, 3 fluoro. So 3 bromo dash 4 dash fluoro hexane. Go ahead and write the names of these compounds. So for the first example, we have 5 carbons, which represents pentane, but it's an alkene, so we're going to call it pentene. And the double bond is between carbons 2 and 3, so we're going to pick the lower of the two numbers, so it's going to be 2-pentene. For the next one, this is going to be carbon 1. We want the triple bond to have a lower number rather than methyl. The triple bond, the alkyne, has more priority than a methyl group. So that's why we counted it from right to left. So this is going to be 4-methyl dash 1-hexyne. So for the next example, you don't want to count it this way. 1, 2, 3, 4, 5, 6, 7, because that is not the longest chain. So make sure you look for the longest chain always. The longest chain actually starts from here. 1, 2, 3, 4, 5, 6, 7, 8. 8 is longer than 7. Now, we need to count in the right direction. Let's say if we count the other way. 1, 2, 3, 4, 5, 6, 7, 8. So here, this is a 3-methyl and a 5-ethyl, or it can be 4-ethyl, 6-methyl. So 3 versus 6 and 5 versus 4. The red numbers are lower, so we're going to use the red numbers. But we're still going to alphabetize it, so it's going to be 5-ethyl dash 3-methyl, and since we have 8 atoms in total, octane. So those are some basic rules that you can use to draw and name organic compounds. But sometimes you might be given the structure in a condensed form. So let's say if you have CH3, CH2, CH2. How would you draw the Lewis structure and also the line structure? So to draw the Lewis structure, start from left to right. Carbon likes to form 4 bonds. The first carbon has 3 hydrogens because it says CH3. The next carbon only has 1 hydrogen, and it's attached to another carbon. But notice that the middle carbon only has 3 bonds. For it to have 4 bonds, we need to put a double bond. And the last carbon has 2 hydrogens. So now every hydrogen atom has 1 bond, every carbon atom has 4 bonds, so that's the Lewis structure. So to convert it to a line structure, we have 3 carbons, which looks like this, and there's a double bond between carbons 1 and 2. So this is known as propene. We don't have to say 1-propene because there's only 2 ways to draw it, and either way you count it, it's going to be 1-propene. So if the double bond is automatically at carbon 1, regardless of all the possible ways to draw it, you don't have to say 1-propane. You could just say propane, because there's only one way to draw propane. These two are identical. They represent the same molecule. So go ahead and try this one. Draw the Lewis structure for this particular compound. So let's start with this carbon atom. That carbon has 3 methyl groups. So a CH3, another CH3, and another CH3. And then it's attached to a CH2, a carbon that has 2 hydrogens. It's attached to another carbon, which is attached to a carbon and a hydrogen. The 2 carbons on the right, they have only 2 bonds. So to make them have 4, we need to put a triple bond here. So if we want to convert that to a line structure, notice that we have 5 carbon atoms in the parent chain. So 2, 3, 4, 5. And there's a triple bond on carbon 1. And on carbon 4, we have 2 methyl groups. So that's how you can expand it and convert it into a line structure. So now to name it, this is 1, 2, 3, 4, 5. So it's 4,4 dimethyl. Di represents 2. Tri would represent 3. So 4,4 dimethyl. There's 5 carbons in the parent chain. So then we have -1 pentyne. And that's how you name it. So now next we're going to talk about the functional groups that you need to know for inorganic chemistry, and also how to draw the Lewis structures for those different types of functional groups. But let's go over some few key points. On the periodic table, we have carbon, nitrogen, oxygen, and fluorine in the second row. Now you need to know that carbon has 4 valence electrons, nitrogen has 5, oxygen has 6, and fluorine has 7. So that's the valence electrons of each of these elements. Now carbon, each of these elements wants to have 8 electrons, and that is known as the octet rule. For carbon to get 8 electrons, it needs 4 more electrons. So let me separate this. This is the valence electrons, and this is going to be the number of bonds that every element likes to form. Because carbon needs 4 more valence electrons, it's going to form 4 bonds to get those 4 electrons that it needs. So it can have a total of 8 electrons. Nitrogen already has 5. It needs 3 more to get to 8. So nitrogen likes to form 3 bonds. Oxygen likes to form 2 bonds. Fluorine likes to form 1. Now let's analyze oxygen, for example. Generally speaking, in its most stable form, oxygen is going to have 2 bonds. But that doesn't mean it's always going to have 2 bonds. When oxygen has 3 bonds, when it deviates from the ideal number of 2 bonds, it's going to have a charge. When it has 3 bonds, it has a plus charge. When it has 1 bond, it usually has a minus charge. Like nitrogen, when it has 3 bonds, it's neutral. When nitrogen has 4 bonds, it's going to have a plus charge. When it has 2, it has a minus. And you'll see that throughout this organic chemistry course. So carbon likes to form 4 bonds, so it's typically going to look like this if it only has single bonds. Nitrogen likes to form 3 bonds. And keep in mind, every bond represents 2 electrons. So 2, 4, 6. Now, nitrogen wants to have 8 electrons, so it's going to have 1 lone pair. Oxygen likes to have 2 bonds, which represents 4 electrons. So oxygen is going to have 2 lone pairs. The halogens, like fluorine, usually forms 1 bond, and so they're going to have 3 lone pairs, so that they can have 8 electrons. Now you may want to save this, take notes, because you're going to see this a lot as you draw organic structures. So the first functional group that you need to know, we've covered alkanes, alkenes, alkynes. But the next functional group you need to know are alcohols. Alcohols usually have an OH group. So an example would be CH3OH. This is known as methanol. Alcohols have the end in OL, all. So methane has 1 carbon, so methanol has 1 carbon. To draw the Lewis structure, the first carbon has 3 hydrogens, and we know that carbon likes to form 4 bonds. But notice that this hydrogen is separate from the others. That tells us that this hydrogen is attached to this oxygen. And oxygen likes to form two bonds. In this structure, carbon has 4, oxygen has 2, and every hydrogen has 1. And because oxygen likes to form two bonds, it needs 2 lone pairs, which is what we discussed in the earlier page. Now sometimes you may get a line structure. Let's go ahead and name these 2 alcohols. So this compound has 4 carbons, so we need to think of butane. But because it's an alcohol, instead of butane, we're going to write butanol with an OL. And the alcohol is on carbon 1, so it's 1-butanol. Here, we have 3 carbons, so propane, but instead of propane, it's going to be propanol. And the alcohol is on carbon 2, so it's 2-propanol. That's how you name it. Now, the next thing you need to know is the types of alcohols that you have. This alcohol is a primary alcohol because the carbon that has the OH is attached to only one other carbon atom, so that carbon is a primary carbon. This carbon atom is a secondary carbon because it's attached to 2 other carbon atoms, so thus we have a secondary alcohol. A tertiary alcohol looks like this. The OH group is attached to a carbon that is attached to 3 other carbons, so that's a tertiary alcohol. That's the common name for it is tert-butanol. If you want to know the IUPAC name, which is the standard name, you need to first identify the parent chain, which is 3 carbons, but we have a methyl on carbon 2. So to name it, it's 2-methyl 2-propanol. That's the IUPAC name, the standard name, but the common name is tert-butanol. The next functional group we're going to talk about is a carboxylic acid. So in its condensed form, typically it looks like this. So let's draw the Lewis structure. The first carbon has 3 hydrogen atoms, and the second carbon has 2 oxygen atoms. You don't want to connect it like this because it's not going to work. Carbon's going to have 2 bonds. So you need to place one oxygen on top and the other on the side. Now there has to be a hydrogen here. You don't want to put this hydrogen on this carbon because if you do it, the oxygen is going to have 1 bond. We said oxygen likes to have 2 bonds, so we can't draw it that way. What you want to do is you want to put the hydrogen to the side so that this oxygen can have 2 bonds. And right now, the second carbon atom has 2. For it to have 4, you need a double bond. So in this format, every oxygen atom has its desired number of bonds, which is 2 bonds. And therefore, they each require 2 lone pairs. So that's the Lewis structure of carboxylic acid. The common name for this substance is acetic acid. If you want the IUPAC name, there's 2 carbons, which represents ethane. So instead of ethane, it's ethanoic acid. You add oic for carboxylic acid. So let's say if you have this carboxylic acid in line structure, this is how it looks like. How would you name it? So first, identify how many carbons are in the parent chain. There are 6 carbons. So 6 carbons represent hexane. So this is called hexanoic acid. The next functional group you need to be aware of looks like this: CH3CHO. Whenever you see the CHO instead of OH, this is an aldehyde. So if we draw the Lewis structure, you need to realize that the hydrogen is directly attached to the carbon, and there's a double bond oxygen atom. So oxygen has 2 bonds and it requires 2 lone pairs. So that's the Lewis structure for a typical aldehyde. So this is called ethanol. It has 2 carbons, but the ending is Al for an aldehyde instead of Ol for an alcohol. So let's say if we have this Lewis structure. It has 4 carbons, so it's butanol. And if we add some substituents to it, let's say if we throw in a chlorine and a methyl group, we can apply the naming rules that we learned before. So this is going to be carbon 1. The aldehyde has priority automatically. So that's carbon 1, 2, 3, 4, and 5. So to name it, it's going to be 3-chloro. Chloro comes before methyl, and then 4-methyl. And there's 5 carbons in a parent chain, so that's pentane, but instead of pentane, it's pentanol with an Al. So that ending, the Al tells you that you're dealing with an aldehyde. So let's say if you want to draw, for example, 2-methyl butanol. So butane has 4 carbons, but because we see Al, that's an aldehyde. And on carbon 2, we have a methyl. The next substance you need to be familiar with is a ketone. Here's one example of a ketone. So if we draw the Lewis structure, the second carbon has a double bond oxygen to it. So this is known as acetone. That's the common name for a 3-carbon ketone. The IUPAC name is propanone. ONE for a ketone. So let's say if you have this substance. There's 6 carbons and the ketone is on carbon 3. Oh, by the way, for an aldehyde, you don't have to say like 1-butanol because an aldehyde is always at the end. So if I put 1, in the last example, just so you know, you don't have to put the 1. So in this case, this is 3-hexanone. Now, I want to compare an aldehyde with a ketone. So the difference between an aldehyde and a ketone is that the carbonyl group, which is the C double bond O group, which is this is the carbonyl group, it's always at the end for an aldehyde. For a ketone, it's somewhere in the middle. So this aldehyde is known as pentanol with an Al. We don't have to say 1-pentanol because the aldehyde will always be at the end. But for a ketone, we do have to specify where it is. So now let's go over this one, CH3CO2 CH3. This is an ester. So just as before, the first carbon atom has 3 hydrogen atoms, but the second carbon atom has 2 oxygen atoms, very similar to a carboxylic acid. But instead of a hydrogen, we have a CH3 on this side. And every oxygen atom is going to have 2 bonds and 2 lone pairs. So to name it, this part on the left is the methyl part, and on the right side. On the left side, those 2 carbon atoms is known as ethanoate. So when you put it together, the substituent comes first, the part with the white out. So it's really called methyl ethanoate. The parent name is ethanoate. So this has to be at the end regardless of this E right here. So let's say if we want to draw another example. So the carbon that has 2 oxygens, that carbon has the OH part. So it's 4 carbons on the left side. So instead of ethanoate, it's going to be butanoate. And on the right side, we have 3 carbons, which represents propyl. So to name it, it's propyl butanoate. So that's how you can name esters. The next thing we're going to talk about are ethers. So here's our first example. So the common name is dimethyl ether because we have 2 methyl groups. And let's say if you have this one. This is diethyl ether because there's 2 ethyls. If you want to name it based on the IUPAC system, one of them has to be considered the parent chain. Let's say this is the parent chain, 1 and 2. So that's ethane. And O with a CH2CH3 group as a substituent is known as ethoxy. So you would say, well, actually, we have to count it backwards. We want the ethoxy group to be on carbon 1. So 1-ethoxy ethane. That's how you can name it using the IUPAC system. So now let's say if we have this example. Let's say we have a methyl, an oxygen, an ethyl group, and a propyl group. So the common name is going to be ethyl, methyl, propyl, ether. For the IUPAC name, this is going to be carbon 1, 2, and 3 because it's the longest chain. Well, actually, this one's going to be very difficult to... Actually, hold on. I have too many carbon atoms. I meant to draw this structure. There we go. So ignore the other example. I had too many carbons. So the common name for this is, let's see, on the left side we have a methyl. On the right side we have a propyl group. M comes before P, so it's going to be methyl propyl ether. You have to alphabetize it. Now if you want the IUPAC name, this is going to be the parent chain. And the substituent, which is the OCH3 group, instead of being called ethoxy, it's methoxy as a substituent. So it's 1-methoxy because the methoxy group is on carbon 1, propane. That's the IUPAC name for that ether. This one is called 1-methoxy methane, if you want the IUPAC name, but dimethyl ether is much more commonly used. Now, if you want to draw the Lewis structure of this ether, it looks like this. We have an oxygen in the middle, which already has 2 bonds, so we just have to add 2 lone pairs to it. So now let's go over amines or amines. So to draw the Lewis structure, nitrogen is going to have 3 bonds in this example. It's attached to a carbon atom and it has 2 hydrogen atoms. So therefore, it has 1 lone pair. And typically, nitrogen is going to have this structure. It's going to have 3 bonds and a lone pair. This is called methylamine. Now let's say if you want to name this compound. This is called propylamine because it has 3 carbon atoms. This one is called dimethylamine. Not dimethyl, excuse me, diethyl. I'll take that back. Diethylamine. Because we have 2 ethyl groups. And our next example here we have a methyl group, an ethyl group, and a propyl group. So ethyl comes before methyl, which comes before propyl. So to name it, it's going to be called ethyl methyl propyl amine. So that's how you name that example. And let's not forget the lone pair that's on it. Now, this is known as a primary amine because the nitrogen atom is only attached to 1 carbon atom. Now, it's a little bit different from alcohols. Now, this is a secondary amine because the nitrogen atom is attached to 2 carbon atoms. And this is a tertiary amine because nitrogen is attached to 3 carbon atoms. So those are some things that you just have to know. So now let's go over amides. An amide looks just like an amine, but there's a carbonyl group right next to the NH2. And so its properties are completely different from amines. So to draw the Lewis structure, the first carbon atom has 3 hydrogen atoms and is attached to another carbon atom that has a double bonded oxygen atom and a nitrogen. So oxygen is going to have 2 lone pairs and nitrogen is going to have 1. So this is, since we have two carbons, we got to think of ethane, but instead of ethane is ethanamide, or ethane and then amide. So this is known as butanamide because it has four carbons. Now we don't have to say one butanamide because the amide is always going to be at the end.